High above the clouds, storms hide a secret no ordinary eye can see. A flash so strange it looks alive, like a red jellyfish stretching 50 miles into space, taller than Mount Everest, yet vanishing in a blink, erupts in silence. For decades, these lights were dismissed as hallucinations of exhausted pilots. But now, from the International Space Station, NASA has captured them in breathtaking detail. What are these elusive red sprites? How were they finally caught on camera? And why could they rewrite our understanding of storms, Earth's atmosphere, and even space itself? Let's uncover the mystery. Ghosts in the sky. Long before science confirmed their existence, whispers of phantom lights haunted the skies. Pilots flying at night reported crimson glows above thunderstorms, ethereal shapes flickering high in the atmosphere. They spoke of vertical streaks, sometimes branching into forms that resembled jellyfish. But without evidence, these accounts were shrugged off as optical illusions, born from tired eyes staring into lightning storms. Some scientists even admitted they feared ridicule if they pursued the mystery too seriously. It wasn't until 1989 that researchers at the University of Minnesota, aiming cameras above Midwestern storms, captured the first photographic proof. In a grainy frame, faint red tendrils stretched skyward above a thundercloud. What was once dismissed as rumor became undeniable fact. Sprites were real. They weren't lightning in the traditional sense. Instead, they were enormous electrical discharges in the mesosphere, glowing red as nitrogen molecules excited by powerful lightning strikes released energy. Sprites are staggeringly tall. Some stretch 30 to 50 miles upward, dwarfing the very storms that birthed them. Yet they live for only milliseconds, too quick for the human eye, too faint for the naked gaze. Unlike the blinding white of a bolt, sprites glow with a ghostly, transparent red. To stand beneath one, even if you could see it, would be like glimpsing a living painting in the sky. Scientists soon learned that sprites erupt after immense positive lightning bolts, rare, high-energy strikes that leap from thunderclouds to the ground. That transfer of charge sends ripples into the thin air above, sparking glowing plasma structures in the upper atmosphere. What makes them even more elusive is where they happen, between 50 and 80 kilometers above Earth, far beyond normal aircraft paths, in a realm where the air is thin and icy. From the ground, with storm clouds blocking the view, spotting them is next to impossible. Even with telescopes, most attempts to photograph sprites yielded nothing but dark skies. Only chance and perseverance captured the earliest frames. But the mystery remained unsolved. How could we study something so fast, so hidden, so high above our storms? The answer would come from orbit, a place above the clouds, a laboratory circling Earth every 90 minutes. The International Space Station would become humanity's eye into this unseen world. And what it revealed was nothing short of breathtaking. The ISS eye above storms. 400 kilometers above Earth, astronauts aboard the International Space Station look down on a living canvas. At night, thunderstorms sprawl across continents like glowing scars, flashing endlessly with white and blue light. But with the right instruments and the right timing, something stranger emerges. Red light bursts into the sky, stretching like luminous tendrils into the mesosphere. Sprites. NASA has turned the ISS into a storm observatory. One of its most powerful tools is the Atmosphere Space Interactions Monitor, or a SIM. Installed in 2018, a SIM is designed specifically to capture transient luminous events, sprites, blue jets, halos, electrical discharges too brief to see from Earth. Its cameras and photometers record in microseconds, freezing what lasts less than a blink. To science, it's like slowing down lightning until it whispers its secrets. Astronauts themselves have joined the chase. From the station's cupola, a 7-window dome pointed at Earth, crew members use high-speed digital cameras to track storms. They wait as the ISS glides over thunderheads in Mexico, Africa, or the American plains. And in July 2025, astronaut Nicole Vapor Ayers caught something extraordinary. A colossal red sprite unfurling over North America. Her photo showed a jellyfish-like form, glowing with a deep crimson body and faint filaments reaching upward. She posted just 2 words, just, wow. The image raced across the world. Within hours, it was splashed across CNN, BBC, and science journals, sparking headlines like NASA astronaut captures ghost in the sky. For once, the world could see what pilots had described as myths. But the ISS offers more than spectacle. A sim and astronaut images are scientific treasure troves. By analyzing frames, researchers can trace how sprites grow, when they appear after lightning, and how their structures evolve in the thin air. The data helps refine storm charge models and could one day improve weather prediction. With sprites forming above the storm, scientists can connect what happens deep in a thunderhead to effects rippling into the upper atmosphere. From orbit, there are no clouds in the way, no horizon cutting off the view. The ISS gives humanity an unobstructed vantage point. And with each pass over storm-struck regions, it turns fleeting flashes into science. Yet still the question lingers. Why do these ghostly events matter so much? What secrets do they unlock about Earth itself? The meaning behind the mystery. Sprites aren't just atmospheric fireworks. They're windows into Earth's electric heartbeat. Every thunderstorm is part of a vast circuit, linking the surface to the upper atmosphere. When a powerful positive lightning bolt discharges, the energy doesn't stop at the ground. It surges upward, disturbing the mesosphere and triggering sprites. In that instant, a storm connects Earth to space. Scientists use sprites to probe this hidden connection. Studying them refines our understanding of how storms distribute charge and energy. With satellites and aircraft measuring from above, researchers can match sprite events with lightning strikes and uncover patterns. This matters because sprites may alter how thunderstorms interact with climate systems. Their discharges change the chemistry of the upper atmosphere, influencing ozone and nitrogen levels far above the weather we see every day. There's also a practical stake. Sprites disturb the ionosphere, the charged layer that bounces radio waves across the globe. That means these events could affect communication systems or navigation signals. For airlines flying long polar routes, where storm systems and geomagnetic conditions overlap, knowing when sprites occur could be a matter of safety. And there's more. Some thunderstorms unleash not only sprites, but bursts of gamma rays, terrestrial gamma ray flashes, that rival emissions from cosmic objects. In a fraction of a second, a thunderstorm on Earth can release as much gamma energy as a neutron star thousands of light years away. To catch these, the ISS hosts Light 1, a CubeSat tuned to hunt gamma events linked with storms. Understanding this phenomenon bridges weather science with high-energy physics, revealing that our planet's skies can mimic the violent processes of deep space. Beyond Earth, sprites open the imagination. If lightning rages on Jupiter, Saturn, or Venus, could sprites follow? Observing them here builds a framework to search for similar events elsewhere. These ghostly flashes might not just be Earth's spectacle. They could be universal, part of how atmospheres discharge energy across the cosmos. What began as whispers from pilots has become a key to Earth's electric story. Each sprite is more than light. It is evidence of hidden processes shaping our climate, touching our technology, and reminding us that our planet is still full of surprises. They matter because they force us to look upward, into the unseen, and recognize that thunderstorms are not bound to Earth's surface. They reach into space itself. Thanks for watching. We'd love to hear your thoughts in the comments. If you enjoyed this video, don't forget to like, share, and subscribe. Your support means the world and keeps our journey going.